Hey guys, Al here, Vitalized Seed. So I wanted to talk about calcium today. So calcium is really something that's often misunderstood or not talked about, specifically in the food plot industry. If you get into standard agronomy or agriculture, base saturations are talked about quite a bit. But in food plot or even small scale gardening and farming, honestly, it's kind of frustrating because I think people just go, well, it's too complicated. But I want to try to simplify it and explain that it's really not that complicated. So we did other videos if you want to check those out about how lime works, and lime can have an element of calcium in it. But let's talk about why is calcium important, and this is just one of many photographs and many articles you can find on if you Google importance of calcium in a plant. But obviously, the calcium benefits cell wall structure, enzymes, disease resistance, etc. A lot of times, people are just simply going to say it helps to transfer nutrients into the plant and through the plant. It's going to help the cell wall structure of that plant so it is more stable. You'll also find a bunch of things like this from various companies that talk about what are some signs of plant deficiencies. Oftentimes, you'll see pictures of tomatoes with the bottom rotten end, blossom end root rot, as that's commonly known. Or in the space, if you're growing cover crops or row crops, you'll see things like this: yellowing, weak plants, etc., due to lack of calcium or, in this case, and magnesium. But today we're going to focus on calcium. So here's another great example of how the calcium acts within the plant as far as the plant physiology goes. So talks about converting nitrate to nitrogen form. So we talked about that before, how you need a bunch of different nutrients to make sure that you get that, I forget exactly the range, but it's, polypeptides and amino acids and everything that end up turning into plant protein. And you need a whole bunch of nutrients in order to do that. And having the right nutrients in the right balance can make that possible. And healthy plants that can extract those nutrients can make that possible. Calcium, it's important for cell division. Strengthening cell walls, improves other nutrients being uptaken from the soil, enzyme systems, as well as contributing to overall plant resistance, which makes sense, right? If the plant's stronger from a cellular perspective, that it should have better disease resistance. So, we talk a lot about base saturations and calcium and things like that. Well, I want to show people, so this is kind of a crude diagram, but I think it works how to explain. You have soil solution that's kind of in the middle. You have root hairs, and then you have your clay particles, which is your soil on the right-hand side. And it shows that as your calcium comes into solution, it gets absorbed into your root hairs and so on and so forth. And it also shows you your calcium, magnesium, potassium, hydrogen, aluminum, sodium. And what's important here, I think, to note is that when you have the correct soil structure from a chemical perspective, calcium, magnesium, etc., that I'm going to go into a little bit more detail on that, as to why you're able to alter pH with lime. You'll notice hydrogen's a single plus charge and sodium's a single plus charge. So when you start to see that sodium creep up in some soils, I've seen that before, it's typically indicative of poor drainage, what can be a couple things can happen. You could have compaction you could have poor drainage just simply due to terrain or something like that. You could have too high of magnesium, etc. Because if your structures are good, you should be able to flush those things out of your system and maintain a good calcium and magnesium base saturation ratio, as well as potassium. You also notice that the aluminum charge and other metals can have really, I think that's 3 plus. The picture's not the greatest, but it's a 3 plus charge, which is why aluminum is not very mobile or extremely immobile in the soil. It also will bind to things like phosphorus, which makes phosphorus more difficult to get into the plant. So what does all of that mean? Well, that means in general, and this is going to vary, but this is just a random chart kind of explaining base saturations. And I thought it was nice because it does it in a pie chart. And if you get a good soil test, like we use Ward Labs, and other labs do this as well, they'll give you these numbers, and it's relative to your CEC of the soil, which is the cation exchange capacity. But what this is going to help us to do is make sure that the chemical structure of the soil is correct. It'll help us pick the right lime sources, and it'll help us make sure that we understand the importance of what chemical or what amendments we have to add, if any, and if we're getting a chemical response or a plant response from adding a calcium, for example, then we can understand Well, why is that happening? And oftentimes it's not because of a pH adjustment, especially if it's just a simple calcium spray, but it likely has to do with the fact that we don't have enough calcium in our soils and certainly don't have enough calcium in our soil solution for plants to uptake. So that's why we're getting this major response. Again, think of Liebig's law of the minimum, where you're seeing something low that's being added, you're getting a much larger yield response than something that's at mid to high level that's being added. You might not see any or very slight response. So this is why it's very important to understand soil structure and chemical structure and how things are going to impact that going forward. All right, guys, so I want to finish on, so now what? So now you understand kind of the roles calcium plays in the plant. You understand the base saturation is going to be a reading on your soil test that's relative to the CEC of the soil. So let's say you pull your pH, you're happy, you're using the Vitalize 1-2 system or something similar, you're maximizing biology in your soil profile, you're seeing good responses, and you're thinking, what else can I do to take my system to the next level? And I don't want to go crazy with inputs. This is where I really think it's fine-tuning that chemical side of the system and also looking at some things like micronutrients, which we'll touch on in another video, and just kind of topping some things off and then just letting biology hammer away using diversity. So in this situation, what I would say is let's throw out that the soil pH is 6.8. It's perfect. You know, you're really happy with it. But your magnesium, let's say it's a little bit high. It's a higher CEC or clay content soil. And your calcium is not exactly where you want it. So you want to add a little porosity to that soil profile. Let's say your calcium's at 55%. And let's say your magnesium's at 25% base saturation and you have a 18 CEC. Because your pH is good, we don't want to go in there and add lime. We don't want to push more hydrogen and alter the soil pH. But we do want to displace some of your magnesium and we want to increase some of the calcium in the base saturation. So this is where understanding antagonisms and synergistic relationships within soil and chemicals is important. So by going in and adding something like a gypsum, or in this case they put in bone meal, but most people on anything larger than like a half acre are probably going to use either gypsum or lime sources to do these things. But let's say you're putting down gypsum. Well, now you're putting down a calcium source that doesn't have a carbonate element, so you're adding calcium to the soil to change the base saturation. It's going to help aid the soil solution, so you're going to have more available calcium for the plants. You're not going to change your pH. You're going to keep it at 6.8 roughly, and you're going to be able to use biology because they have more porosity for more good biology to flow through the soil. You're going to have better water infiltration, etc. So that's one example, guys, of one nutrient that often gets overlooked. So just because you get a response from something that's calcium, or if it says it's going to change pH or whatever, but it doesn't really match up with what the science is as far as calcium carbonate, that doesn't mean that it's not working. It might just be working because your soils are really low on available calcium and you're putting calcium on that plant or near that plant's root system, and that's why you're getting such a positive response. But don't get disheartened if your pH didn't change next year. You might just have to actually go back to a lime source to alter that pH, and then forward look to agronomic science as to how we can better the soil structure going forward. So it's soil structure, pH, biology, all working together. You can get a lot done, guys, in a short period of time. Hopefully you enjoyed that. Check us out at vitalizeseed.com, and please share, subscribe, and follow along.